we have used virtual machines up until now to create and destroy machines and run applications inside those virtual machines.
Right.
Virtual machines are, right?
It's a cool story.
Yep. And so virtual machines are a representation of real hardware. They're not real, they're virtual. They represent everything inside you will find typically in a machine. But a new technology has emerged in the last few, maybe years, I would say, and it is now getting mainstream. And this technology is a technology called container technology, and that's what the Docker is. So it gives you a container. What essentially it does is, think of it like this. Start thinking in a different way of so different frame of reference is needed to think about what containers are and how are they different from virtual machines.
It's a sandbox, isn't it?
It is sandbox. It is exactly sandbox actually. So now, how do you think about that? I would like to give you some examples that you are probably very familiar with, but you never thought of those things as a container. Containers are essentially giving a boundary around something. So you have a garden, and it's a beautiful garden, all green and all that, but you have kids who want to play in sand. How do you enable that? You put a boundary inside somewhere, put bricks around it, and put sand in between, and put your kids in that sandbox. And you contain their actions and then let them play. They get the contained environment that they want, and you still have a beautiful garden. Hope that they don't come out.
So really, it's the same principle as you've got your regular Windows machine and you're running Trusty. That's your sandbox, because you can.
Yes, it is correctly. It is sandbox. It is totally isolated environment, but it's a full baggage of everything along with your hard disk, your operating system, your network card, your graphics card, your applications, your sound card. The whole thing is needed to make Trusty work. In case of this technology, you don't need all that underlying pieces, is what the idea here is. So think of it this way. You buy a new iPhone or you buy an Android phone and you open up the camera first time. What happens? Do you remember?
Yeah, it's all the little hints.
No. Yeah, hints and then some permission requests. What are those permission requests? Do you remember?
Like your Apple.
No, it is security. As in, you'll remember, camera will ask your phone, your camera, and your camera, when you start it first time, it will say, can I access your GPS?
For geocaching.
Right. So what is going on?
It's sandboxing that app to not allow it to interact with anything else until you give it
Till you
permissions.
explicitly permit, right? So you have to request for permission and allow that as a user, as a supervisor of the device, to allow camera application to talk to the GPS. Sometimes you again install Skype application on a phone, and Skype starts first time. Skype will ask you for permission to use the microphone, permission to use the camera. Again, what's going on? Same thing. Skype cannot access your camera without your permission. Skype cannot access your microphone without your permission. And so these other things that are outside the container cannot be accessed. They're isolated. You don't really create a complete machine in a virtual box inside your iPhone, but you're essentially creating boundaries around. Hey, you can play in this area and you play in this area, and all of us happily live together. We'll talk as needed, and so camera will access GPS information and embed that into the photograph so that it knows where the picture was taken, and Skype will be able to access the video camera or the webcam or the camera you have back and front, and also listen to the microphone and speak out in the speaker, play in the speaker, and so other parties can hear you and you can hear them and see them and be visible to them. And these aspects of requesting explicit permission from another application, even though it is the same machine, is the behavior that you will see in a container. In these containers, you don't have to worry about installing an operating system, because you already get it from the underlying operating system, becomes available to you, and you put your applications, just the apps, not the whole thing, and you have it up and running in an isolated environment, just like VirtualBox will do, just like an EC2 machine will create, or a DigitalOcean Droplet will have, or a HP Cloud machine will have. So completely isolated environments you get without the baggage of underlying technologies to move along. So remember, when I gave you Trusty the first day, it was a 5 gigabyte file. It is painful to copy around 5 gigabyte files, even in same room. It is painful. It is a whole lot easier to just transfer 5 kilobytes, maybe 50 kilobytes, or maybe even 50 megabytes of something compared to 5 gigabytes. It's cheaper, easier, faster. And a typical application alone is small. A machine image can be big and is typically big. And so it takes 55 seconds for a DigitalOcean Droplet to get created from a blank image that you start. You select an image, takes 55-second guarantee that they have. You know what guarantee Docker gives? Sub-second, less than a second. And you have a new container and your app is running. And you can see it as we will start it in just a few minutes. Do you get the concept clear? What are we dealing with is not the baggage, just the app, just the meat, just the useful component. Because we'll expect and assume the underlying skeleton to become available to each of these containers that we'll create on the same box. We'll create independent containers and put stuff in there. Put various different types of applications in there. So if you think about our trivial example that we've been using all along, which is the LAMP stack. You have Linux, the underlying foundation. You have Apache, then you have PHP language, runtime, and then you have some kind of a database to store your data, and Apache web server will serve the web application, and you can install WordPress, you can install Wikipedia, you can install Drupal, you can install a bunch of other applications that are LAMP based. So that's the idea behind this environment. And so in case of what I just described, if you happen to have a situation like that and you can create a container containing LAMP, you can just put applications on top in isolated in containers and use the underlying LAMP framework as well as the Linux underlying as well as AMP all available to you, and on the same machine you can have another container running Ruby and another container running Java and another container running Python, and provide the underlying operating system support from below. So you don't have to install Linux on each of these boxes or containers. Just worry about the application and its dependency, what is needed from the underlying OS. You need some of the basic stuff like AMP for LAMP. You need Ruby on Rails for Rails application in Ruby, or you need some Python and Django installed for a Python application to run in a container. So the underlying infrastructure will give you that. You don't have to worry about creating all that. You don't have to, you can very easily start and stop containers in sub-second or even less. And that technology is evolved into a point where it is now getting to mainstream. And if you remember, in the first month, almost about the end of the first month, we used Heroku as a platform as a service, PaaS, where we created a simple Rails application and deployed it on Heroku. And the process of deploying on Heroku, essentially Heroku will run on Amazon EC2, and so they will start up a machine for you and then install Rails, and then you load your application, and all that jazz takes a whole long time. I mean, maybe 10s or 15s of minutes roughly. In case of this technology, which came from another company, which now competes and very beautifully with Heroku, is the company is called .cloud, and this is a platform as a service that competes directly with Heroku, except these guys do not have to worry about creating machines. Instead, they just create containers and deploy your app in less than a second, and you're done. And they have, as a side project, some time ago, created their entire technology and open sourced their product called Docker. And so these guys, in fact, there is a Solomon Hykes, this guy. He released his product in the open source, and he is probably younger than you guys. And his product is taken on and is immensely popular. It's open source, and this product is called Docker. It has been adopted by Google. Google creates 2 billion containers a week or some obnoxious number like that, but they are big. So they're 2 billion, not million, B as in, yes. So it is huge. I don't know what. So let's see how many containers Google creates. Google creates. So container technology is not new. Docker is new.
Okay.
Google creates containers.
Google uses Docker?
Yes,
Right.
yes, they are using Docker. Yeah. Many companies who are using Linux are using Docker. So Linux is needed for Docker. It doesn't work with Windows. It is Linux only. It is not Mac either. So it's Linux only. Specifically, you have to have Linux, and there is a new Linux distribution has come up called Core OS that is designed to run containers by design. By the kernel itself, it is rewritten to support containers. Question.
I got a good question. I'm trying to wrap my head around this first. So Docker is pretty much just is pretty much a pass, right?
Docker is not a pass. .cloud is a pass.
.cloud is a pass. So pretty much.
Docker is a container technology that helps you deploy your app in your container. It's not a pass by itself. It's not a service. It's a product.
Okay.
.cloud is a service like Docker,
Okay.
or rather Docker is like .cloud
But
technology.
you literally are just putting there just your code in your.
Yes, you will put your code and you will see a container.
Package means
Yeah, Git package can be a Git check-in, Git commit.
Oh, okay.
So whatever you write is your application, or your developer writes is your application. It will be in a Git repository, and you deploy that Git commit to a container, and you have it running. You don't have to worry about all the underlying pieces because Docker helps you with that.
Okay. Yeah.
Got
I don't know if my knowledge is right, but it's like installing an app to your phone, and your app is your Git, and you're pushing it to your.
Yeah, so you download an app from the App Store.
Yep.
Same concept.
Okay. So that's,
Similar concept. There is no App Store here, but there is GitHub.
So your GitHub's your main links. Okay.
There are other pieces like GitHub, like Bitbucket, or like your own GitLab. GitLab is open source, so you can like create GitHub-like setup for yourself in your company, if you like. So maybe we should do some hands-on to understand this.
Yeah.
I'm a hands-on guy. I can't do background shit.
No.
Yeah.
I'm like trying to differentiate like what is the difference between what we've learned like and what's the new
So
thing.
this new thing is speed. Really quick deployments. Really quickly create a container in less than a second, as opposed to 55 seconds. It's quite a bit difference if you think about it, right?
If you multiply that by 100, 1,000.
Yeah. Think about it. It's quite a bit. It's 55 times roughly.
So when you say deploy new codes, new
Yeah,
programs,
new everything.
right?
New everything you want. You want a place to put your stuff. Here is a container. You don't want it anymore. It's gone. You want more? Here's more.
But these are pretty much rapid deployments.
Yes, that's what it says. And massive.
GitHub is
GitHub is a
where we put
GitHub
our
doesn't. GitHub is where you put your code. Doesn't run it.
Yeah.
Okay.
In a container, it actually runs.
Okay. So GitHub is storage, your containers is your actual platform that you run it off of.
Let's see, what's a good analogy for this? So you're a robot.
Oh my
Okay.
god.
Alright.
Just get out of here.
I'm Googling.
So
Differences
Git-
between
Hitchcock counter.
GitHub,
Yeah.
GitHub is like a fuel tank, and car is the.
Yes. 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 Yes.
Platform service again is just like
Platform is that a service that provides you a place to run your apps, and it
just like
will
if you were giving Linux as a service, that would be a platform.
that will become an OS as a service. So you have to provide Linux plus some more things to become a platform,
Plus a few more things.
like Rails, for example.
Okay, got it. So it's more than just the OS.
Yeah, more than just the OS. If you just get the OS, it's easy too. It's like infrastructure as a service where you get the machine and then you put the OS.
OS, and then so you have your OS as a service, and you can get more. Like
Yes.
Core OS is a,
OS. It's an OS, like Ubuntu.
but it runs containers.
Core. Yeah, it's even Ubuntu will run container just fine. We'll see it right now. We'll use Ubuntu first to run container technology. Right?
I've always been like.
Where do you use Docker?
I don't think there's
I have
internet
a
anymore.
master's
There it
in
is.
science,
Okay.
and I did MSSA.
I have enough internet on my phone
I work in
this month
IT
to give
for
everybody internet.
I could teach that.
So you can log onto my phone. That's not working. I got up to 10.
And in college, I did.
I think it gave me 40 gigs this month, so I'm good.
Okay.
And that's
You
from like
ate
now
it?
till the 8th.
40, that's
Okay.
good. I have it unlimited.
So are you deploying apps right now?
University?
Just very simple.
Just create containers. So understand containers first before we get to deployment.
Question.
I'm
Now you're actually probably doing it. So you're gonna take your repository.
We're not getting the app level. We just create containers right now. We'll get to the app also.
I actually worked with.
Calm me down. Calm me down. Trying to figure it out.
Yeah.
She says
Makes sense. Makes sense.
She says it's hard.
So there are the steps. The steps that we want to do today are written down. They're written down in library. Search for Docker.
We should do printouts for all these.
It's pretty
you know,
good.
for
He's
these,
like only 28. The
Huh?
guy. He's only 28.
Is he really?
I'm 23, so I'm gonna be that guy.
Yeah, you could be that guy.
So go to what is Docker or
No. Go to library. Search for Docker.
library Docker.
Library doctor.
Those were like a bunch of underwear.
with each other in the library.
So hot right now.
You actually got that. That's funny. It's funny that you know what I'm talking about, though.
Yeah.
Oh, you heard library.
Thank you. You know what I'm talking about? You want me to see that? You need to go up to Urban. Go to the Urban Dictionary.
You have any fun, Daniel?
I don't
feel that they picked.
Go look it up.
I mean, our page not good.
It's the weird thing.
Yes.
Right now, because I took it as
You think I am brand new?
this is the first
You
year.
didn't get the
First year
joke.
right after that.
I was thinking.
So-
I'm looking at the date. I'm
This ain't
looking
amateur
at
hour.
that brand, like trademark that it'll come in my resume.
You got an Operation Big Job today?
All the
Okay,
experience,
library.
all the IT exposure. Just need about a year or two. Asking adding.
Library.classroom.
So the idea here that you see is on the library you search for Docker, and you will find this site. On the library you will search for Docker and you will find this site, and you will need to run inside your trusty virtual machine.
Trust
Inside Trusty?
Yeah.
Oh, I should have started my Trusty long time ago.
you. You need like a.
You need to remind us at the beginning of class, please class,
Start Trusty.
Start Trusty, because it's going to take from now until the end of the speaker to start up.
Nah, that's not true.
That's not true, but it's
So close to buying a MacBook Air during Black Friday.
Don't do it.
I stopped myself.
Don't do it.
It was $250 off at $7.99.
Oh, you want that?
But it's only at 4 gig.
When I get the...
Yeah, it was 4 gigs.
you need more than that. I got 4 gigs in mine. It's not enough. I'm looking at. I got 700.
So there is a place on the JBLM that gives you a discount. That doesn't work.
There is, and there's
Yeah.
other ways.
Tax free.
There's other ways to
Yeah, it's
get
tax
a
free.
discount. You need to
There's
call
online too.
Apple.
Online version you can buy online.
Call Apple.
How much did they give you?
They can give you a giant discount if you call Apple.
Veteran?
Not many people know about it, but if you call and talk to the customer support,
They
you
have
call
their
the
number.
customer
It's
support-
government. It's government
No.
military.
Well, they'll look at refurbished machines for you. They'll look at everything that they have, and a lot of time they'll give you a big discount. So that's what I did with mine. First time I ever got.
How much you pay? 700?
No, when I first got it, mine was like a $2,500 machine
That's not discount.
that I got for.
It's not done. I love this.
2000?
Yeah, so like $500. $100 off.
Do I need to send him a picture of me? Maybe get a bigger discount?
So bottom line, we need to have a machine up and running in DigitalOcean, and we need to select a specific image. The specific image is already enabled for Docker. So if you run this image list like this, you will find it.
Oh, JK.
Otherwise, no discount.
I'm gonna get fired.
Library, right? Library at $5.
Why?
We get 2 new hires.
Female?
Surprisingly, yeah.
Surprising.
Hey,
Yeah.
DigitalOcean is hiring.
Where
I didn't know
at?
that they were a startup, and they started from Techstars.
Who?
They're DigitalOcean, and they're valued at 25 mil right now. They're looking at the startups on like the startup programs here in Seattle.
Hmm.
And if you guys ever heard of Techstars, they pretty much if your startup is good enough, they'll finance you about 100 grand for 10% of your equity for your company.
You say, oops, in Cloud Genius, I can't find
You
the
know,
library.
the people they'll mentor you is like from like big companies.
Why you can't find the library in Cloud Genius?
Library.cloudgenie.us.
Yeah. You say, oops.
Library.cloudgenie.
I'll try with you.
So,
No, I'll try again. But this thing is like so.
All on the same line.
oh, I got it. Freaked out. Got
I'm
it.
watching a movie apparently. I know what I'm watching.
Oh no.
I know what you're watching. That might be bad. I'm gonna turn
We're
turn
gonna
down the
watch-
volume.
You're gonna watch your content, dog.
Come on.
I see it. I see it.
You're not even worried about it.
So you want us to create a job link?
You want me to create droppings?
So I'm not worried about the password. You know why?
It's yours now. It's
Yeah,
just
your
copy
phone
on me.
We'll hijack your phone too. We'll clone it.
There's a little verification.
Okay, my trusting's not working. Oh, that's working.
The answer that.
This is
Go where?
two-factor.
Go to your face. Go to Fish Library and put Docker.
I thought he was gonna start his car again and show up.
How many are we here to survive? Something.
Hey.
Numbers.
Numbers.
Well, one guy
Mine's-
was
mine's
pregnant,
up
but he's due soon. But. And then not a lot of people are a fan of the Commander in Chief, so. Did you not catch that yet? Commander in Chief is in the class. That's why he's always late, 'cause he's at a golf game or something.
Polo practice.
He had to discipline his driver on the way here.
No, some like when he was in Washington, some
I
chick
told
was
you
like
to drop me off.
had to give birth on the highway because they wouldn't let.
So you want to make sure to start this machine image, right? Do you find this machine image,
I'm slow.
which is
She's at work.
a Docker image specifically for Docker? That's what you want to get, because this has built-in Docker ready to use.
So just run that command, knife DigitalOcean.
Yeah, this command will give you all the machine images, and you will find one of the results is this.
Okay.
That's what you want to get.
But you already have it there
Yeah,
on this side.
yeah, you can use it. So you don't have to run the command, but I'm just giving you how to find the number.
Yeah, I had to do the hard way where I didn't realize that there was an image list in Knife. So I actually had to search like Google, like all the image lists.
Oh my God.
Remember that when I was trying to get that?
Yep. Correct.
That's terrible. Terrible
I
time.
still want to do OpenStack.
There it is.
Oh, sweet. Did you do it? Did you do it?
Yeah, I used Fedora 20 because like the CentOS I have was I think a bad image, but I copied 3 different versions of it and it still won't work. So I was like, okay, I had some problems with it. So I had to use Fedora. Fedora was good, but it slowed it down because I had to do the UI because I was a new shirt. I didn't realize that I can just install the UI.
Yep.
So cool.
You don't need to install the UI, but it's okay to install the UI. It will still work with the
It's
UI.
slow as heck. If you, I'll tell you that it took me 5 minutes to, 5 to 10 minutes to.
Because your resources are gone, right? Your
Yeah.
resources are gone and busy with the display itself. And you don't need all these things.
You gotta be user friendly. User friendly.
So we want to run the particular command here to start off a DO droplet with Docker built in.
My thing's corrupted. Not cool.
We have to do, we can do the same SSH keys.
If you want to just watch and you don't want to do it, I would need one volunteer and I'll do it here. Bring your machine if it's running, if it's up and running.
Mine's up and running.
If it is running your trusty, yeah, watch it.
Thank you.
So connect and project.
Hijacking.
You know how to project?
I noticed this, but Aaron likes to do people's stuff.
So go drop down in the
I do
Wi-Fi.
not like stealing people's thunder.
He said the
My thunders. Thunder, buddy. What do you want me to do?
Change your Wi-Fi.
I'm learning about Tiz and SDK also. So I was going to develop a small app for the watch. But I don't know what it means.
So change your Wi-Fi to Cloud Genius and project. And now you can project. Can you?
That's the megabytes on my RAM that I have left.
Right.
Like, I don't know. I guess I can project. Maybe.
What's the password to trusty?
It's Cloud Genius. Yeah. So that thing that comes up,
Here.
yeah, just project to Cloud Genius. There we go.
I've never seen it.
That part of that. Just remove it?
Still need to go here, right?
Block out the little Cloud symbol.
Yeah.
Yeah. I'm still working on that.
Yeah, it came up.
From then it happens.
Oh, I just lost my computer.
It's coming up.
Yeah.
Okay. So let's get to that site. Docker.
Yeah.
Is this it?
Docker. Yes. Yep.
Breakfast doesn't have a caffeine.
Your machine is behaving slow.
I need to get more RAM.
That's what I bought for Black Friday. I bought
So I've got
8 gigs of RAM for my
like
desktop.
that's how much I've got 4 gigs and that's how much is available.
You will slow down the whole class.
What?
With this, you will slow down the whole class.
Think so?
I think so.
It doesn't usually.
Oh wow, that's really nice.
So let's see if we can close some stuff out.
Hey Arjun,
Sorry.
can you come?
Come fix this.
Bring your laptop and run with it.
There you go.
It's ready.
Okay, go ahead. But you have a very low RAM situation which will bog us down. That's my concern.
Okay, we're gonna get rid of some
How much RAM do you have?
4.
He's running 100 things.
I have 8.
I'm not running 100.
No, only 238 things.
Look at all that crap.
That's what happens when you steal somebody's from the.
It's called folders. The emails
Thunder Heat.
you can use.
His name is TS.
Okay.
Oh, start calling him TC. Thunder Heat.
So,
TT.
That's how you gotta call it.
Alright.
Politically correct.
so on the terminal inside Trusty, you should have this Docker thing open on one side and a terminal on the other. And let's try to figure out how to get it to work. The first key thing is, man, your machine is slow.
I don't know why it's so slow.
This class,
Amateur hour, dog.
I wasn't slow before this.
No.
I know.
Command.
Trusty made you slow.
It gave me error when I ran that command.
Hey, is any of your display HDMI output capable machines? Do you have them here? And that is running Trusty comfortably.
Yeah.
Yeah, please bring it. Please bring it.
Get it, Margin.
No.
I'm ready. Fire.
I'm going to do Jim Carrey stuff.
I guess dude, I'll do that.
Maybe.
Okay, let's run with it carefully.
Jim Carrey.
So by the way, Jim Carrey is awesome. Yeah.
Do you have any extra Mac RAM lying around?
Mac RAM?
Yeah.
It's in the Mac.
Mac RAM.
You cannot remove it. It's not removable. It's not removable, and this
Well, not in that. No.
no cannot remove here.
Mine it is.
Yeah.
Can't you like actually make some of the actual hard drive?
So let's try to understand what we are doing here is
Like manipulate the actual
this needs to run inside your chef repo. You need to run this command inside your chef repo and it will work.
Someone doing that.
So you should go inside your chef repo folder.
Okay.
Yeah, beautiful. Run it inside chef repo.
What am I running?
I didn't remember. Oh, it's Chef Repo, right?
Chef-repo
Run the
probably.
fail command / facepalm.
Yeah. So here you run up twice. No, not dot chef. Run this command. This one. Yes, it will give you a list of all the images you have in DigitalOcean, and we will select the one we want to use today, which is the Docker image.
There you go.
So in this list of images, we have one of these. The number changed. I had an older number here,
Yeah.
which is fine to use this number instead. It has
Yeah.
Docker 132 and I had Docker 131. That's the only difference. We can use this number today. So copy this number and use it in the documentation. That's the reason why I don't just give number only, but instead give you instruction how to get the numbers for images. So you copy that number, and this is the number you will use here in the browser window for this DO droplet starting. So you want to start the droplet like this, for which you need to write that command in a notepad. So you go here.
I already have it. Oh, you have to be in Notepad?
No, it doesn't have to be notepad. This is good. So
Okay.
just change this image ID to the new number you got
Change it like that.
and paste it. Now you have your key ID. Is that your ID or my ID?
That's your.
So you have to find the ID number for you. You would go that SSH key list command will give you the SSH key ID, and the ID command is available here, and the write up you will also have it. The command is knife DigitalOcean SSH key list digital_ocean SSH key list. And what we are really trying to do is find out what's the ID for the command that we
Key or key?
no plural.
Okay.
Don't you have the dashboard?
Yeah, enter, and this will get you your key number. You want to use this key 408554 for your case, and everybody's key number will be different. This is the public key that we gave to DigitalOcean in their account, in our account with them. And so we want to copy that key ID and go to our notepad, and in that notepad we paste the number. We have our identity file correctly mentioned, which is useful, and we want to now take this whole command. What it does is bootstraps, or essentially starts a new machine in the cloud. This is a virtual machine we are starting. This is not a container. We'll run containers inside that machine.
Paste it.
So this will take 55 seconds, but
Paste it?
yeah, paste it. And when you paste it, your capital K.
Oh.
So this is the translation notepad translated that into capital K for you. Autocorrect,
Which one?
auto capitalize K.
What's the first command you run? The knife DigitalOcean image list, right?
Yep, we found the global image list, not just our
I'm not
images,
doing anything when I do it. It just tells me that I did not provide a valid.
because you're not in the right spot. You should be in the. What happened? What did you type?
Did
Yeah,
you copy
we-
and paste the command?
I
Chef
type.
repo on Mac.
Let's examine the command again.
It should just
I want to see the
Probably a
command,
dirty copy.
not like this in the notepad.
Notepad.
Yeah, here is good. Here is good.
He likes being dirty.
Damn nasty girls.
Scroll up a little bit. I want to read the error.
Nico's a nasty girl.
Oh yeah. Yes, I am.
What did Nico? So why'd you go guard instead of reserve?
No.
Got it.
Because I'm 11 Bravo and there's no 11 Bravos in the reserve.
Somewhere about this, there's an error message.
Yeah.
No, you have to go through the mouse.
Echo.
ready to
Was
go.
that
first.
If I scroll up,
Yeah.
it was way high.
Surprisingly, there's a lot of bad guys and like guys
Where's
probably
the
know it's
Explorer? I'm trying to find. Oh, you're right there,
my,
Explorer.
two of my guys in my squad right now is Alex. I was like, well, okay. Well,
There you go.
shit, I thought I was gonna be good shit here.
Oh, yeah, why? I don't know why I was looking there.
Biggest mistake.
Yeah, if you left the state, not
Yeah.
to a non-military state.
If I would have went home to Chicago, I would have been decent.
So I corrected that after that.
Yeah, you have a typing mistake. Identify file, it's identity file.
Pretty safe.
So it's identity file.
Okay, okay. Yeah, I can go down, right?
Well, yeah.
Identity, and your capital K should be lowercase. So identity file as opposed to identify file. Now you get the command, copy it, take it to terminal and run it. And when you run it, you have a Docker machine ready. And that's when the game starts. Until that time, we don't have anything to run Docker in. So we now have a machine. And so this will create a new DigitalOcean droplet containing Docker prepared for us. Between the day I used it and between today and that day I used it, like just a few days ago, we have a machine image change. Docker updated from 131 to 132.
So waiting for SSHD.
Right, that is expected. It's 55-second delay where the machine is actually starting up.
And your money starts draining.
Your fake money. This is a coupon, right?
You probably spaced it and then put that coupon on there.
Oh, I haven't checked that. I haven't checked it.
He probably has one.
I'm glad I have Windows today. It's that MacBook, you know.
Oh.
Yeah, it actually works.
Only says that the RAM is low.
Okay.
Hey,
So-
because he wants to download the HD good stuff.
Alright.
55.
It's-
We are just doing the virtual machine right now.
We are creating a virtual machine in the DO cloud and getting us a droplet. In that droplet, we'll have Docker running already because we chose the right image.
Okay.
Typically, we choose bare bones, just Ubuntu, just OS images, and then deploy whatever we want. In this case, of the example that we want to run is Docker example. So we deliberately chose a machine image that contains Docker pre-installed to save us some time.
Right. Makes sense. It's a good idea.
So once the Docker box starts running, what we will do is from our trusty just connect to the DO droplet and then play in that box, directly play in that box and create containers and create multiple containers, see how things differ. And you can even go to the extent of deleting and destroying critical files in the operating system, while you can see that inside the container you destroy the whole thing that you see, and still it does not disturb anything else outside the container. Your Ubuntu box that you have running Docker in DigitalOcean will not get impacted at all. You can shoot yourself in the foot and it's okay. You can see that.
It's done.
So you have an IP address, you should connect to that IP address by saying SSH and then connect to that IP address, root at that IP address. So SSH, and then you have to provide your private key and then so -i, SSH -i, and then path to space -i, path to private key -i, path to private key. So it's tilde home slash no home. That
Still did, yeah.
It's a safe repo, right?
no, it is in .ssh folder,
Oh, yeah.
and your private key is named id_rsa, and that is the name of the file which contains your private key. Now you space it out and then say root at IP address, and that will take you inside the DigitalOcean droplet.
Got my password.
Connection closed by the.
Try again.
I know why you're saying that.
Huh?
Yeah.
I'm getting the same message.
Because you all get the same IP probably.
You just need to put SSH root at the IP address.
Oh, really?
Yeah. Well, that's what it's saying on here, on
Yeah.
the library.
That is correct, but this is also right.
Where do you find your
in,
password at? That's bad. I can't connect to my shit. Your mom's house.
Who else is having the same problem?
Oh, I can connect to mine, but my problem is I forgot my password.
So you go to DO, reset your password.
I did, but where do you like get
It
it?
will be in your email.
Oh, okay.
They'll send you an email with the password.
Well, where to count?
So something is broken. This is a sign of something broken with DO.
Ooh, Dio. Hanging you ain't doing stuff, man.
Dio. Whoa.
You said not accessible. And now what?
Yeah, let me take over. I'll take over. Take this.
Don't need this anymore.
Yep.
I do whatever I want. That's how I get it.
Oh yeah, you can get, in Houston we have a problem here, that's the same thing. Yeah. You actually talk?
No.
Yep.
So I'm doing the same steps, but again from beginning, and slightly different route this time to avoid a problem that may exist. I don't know where the problem is, but I'll find out and solve it. I'm taking a slightly different route,
Whoops. I think I got it.
and here's what I'm doing. You can watch it, see it visually. I'm going to create a droplet visually this time by looking at it.
Okay.
I'm going to name it Docker and choose a region called San Francisco.
Okay.
Choose an application that I want, but I really want to have an application, not a Linux distribution, but an application already running. I want to use this ready-made Docker. So I want to use ready-made Docker as I show you here, and then add my key and then create a droplet. This will create a droplet, takes 55 seconds, 60 seconds apparently, and then I will have a droplet, and then I will take the, I have my key.
Do you have to have a Docker account?
Docker account is optional.
What?
You can make a Docker account by going to Docker Hub and create an account. It's that simple.
on your
Instructions say login, not necessary. It's optional.
Oh, so this is just for easier.
Yeah, if you have it, you can log in. You don't have to have it. Docker account, Docker Hub account is like GitHub account. It's free. You log in, you create an account, and you use it. Docker Hub. That's where Docker images are available.
Hello world.
And you can use your GitHub login and log in through GitHub, so it just takes you there.
Baby, I can take you there.
So by now I think my Docker machine is active. I should be able to log in to that machine, and if it doesn't, I will find a different way to log inside that machine. So right now I am clearing it and saying SSH and root at IP address.
You still have to be inside the chef repo, right?
Not necessarily. If you're not running a chef command, that particular command doesn't need to be in chef repo.
So here in your part where it says here we launched 1.2.14.04 image and also passed to flags.
Something is bad today. It is not running. No.
Waiting for him.
There it is. Okay. So yeah, now I need to reset the password.
Oh, well, that might be my issue too, right?
Maybe. I'm going to get through the back door and access and reset root password and get in.
Do that.
So when I do that, I will receive an email from DigitalOcean giving me the password that I want to use with this machine. So I will be getting that momentarily. And so I received my password and here it is. So now I should be able to use the password to log in like this.
Wow, this is a long.
What is that song?
Yeah.
Tutorial is long.
Yeah.
Walk right into it.
I know.
Should I make it short?
Need cold. You need colder temperature.
It's not working for me either. See? Oh, there. Finally it asks for a password and I am in. Okay.
That's what she said.
It's recorded.
And connection closed.
So thank you coming in.
No, come again. Sorry, you were going to.
Okay, let's try one more time. If it succeeds, that will be nice.
What's the password that I need to enter?
Okay, the password DO will provide you. DO will give you your password. You have to reset your password if it's giving you trouble, like it was giving me trouble. Now I am inside DO.
That's what they're calling it these days.
Oh, inside that shit.
So we'll run another command or?
No, same thing. Now we just finished the SSH step. So I'll go here. In this step, I just finished this step. Connect to your Docker instance. That's what I just did. Connect to your Docker instance. I just connected to my Docker instance. Got it?
I couldn't still command. So what was the issue that?
Did you reset your password?
But I can't type it.
Reset password where?
The doctor gave you?
Like literally, I went to my gedit and typed if my keyboard's getting captured, it's gonna capture, but it can't get captured here at terminal.
Because that's when the last
Right click.
just had to do.
So go to the Docker website,
Say capture.
reset password.
Oh, there's my password.
type.
Aha. Got
That's in
it.
your email?
Yes,
But
Ah.
it's getting captured here.
Huh?
it's my email. Yeah.
Break terminal.
Which email? I
Break it.
can't open any account in Docker.
No,
Break it as in close it out.
DigitalOcean sends
Okay, oh, open it again.
connection
Yeah,
closed.
kill. So let us see if we can reach this point and then we can start experimenting with Docker. So at this point I'm going to assume that if you are going to manage your own DO droplet, that you have connected successfully like SSH root IP address to that Docker box like this. That you have done it already is what I'm going to assume and proceed. Are you ready?
Yeah.
Okay. So first thing, you check Docker version. It's as simple as asking, hey Docker, what's your version? Like this. 132. Got that?
Get your digits.
There we go.
You got the number 132. By the way, we'll examine some other things here. There's a client API version 115. It uses a Go language. The language is called Go programming language. And that Go language is version 133. These Docker is built in Git. And so Git commit reference is also provided just in case you are interested in finding out the particular commit number for Git for Docker. And so all these details are available here for just finding out what are you dealing with. Docker updates every month. So it's pretty rapid. Next up, you log on to Docker registry. This step is optional, but you essentially log on to that registry, which is like Docker Hub that I discussed here. And so here 1 week ago I pulled something and I pulled something else, and so all actions are showing up here as I do it, provided you log yourself in to the Docker Hub, and that will be simple as Docker login. And you log in and you give your password and you put your email address, and then you move along. It logs you in basically, and any actions subsequent to that, push and pull. So Docker is pretty much like Git. It's not Git, pretty much like Git. You create your environment and you can commit and push it, and you can reproduce the same environment by pulling it down. So you create a complete environment like you want to have Ruby on Rails and all these things that you want to get deployed. You prepare your environment inside a container and then commit, and then you push it to Docker Hub, and another container you can just pull it down, and it just becomes available. That's the reason why it is so fast, because you don't have to repeat your steps over and over again.
So those are just copies?
Yes, but your copies, so your iterations of changes that you will keep track, it is based on difference. Copies are based on differences.
Would those copies be automatically updated if you updated your master?
No, you have to update.
That's where Chef comes in to automate.
Yeah. Yes. Next up, we'll create a very simple application. Very simple application. We'll begin with hello world. Hello world. And so the way to run it is, if you want to run, so let's say I want to run hello world here, I will say echo hello world, right? That will basically say hello world, and it does it right in here in the do droplet. It's not a big deal. It's like the Mac command, you have say something, right? It will say something pretty much like that, echo, it will say that.
This does it to your console?
Yes. Yeah, any terminal, including PowerShell, it will work like that.
Stop calling it console. I can't remember getting it. But console is like for programming, like on.
Yeah, console can have different meanings. So programming console, terminal console. This is also.
Sure, why not? It works.
Right. So we saw this simple thing running. Right. Now we want to run this same thing, but now inside a container. So what we want to do is, first of all, create a container, and you create a container by just running it and choosing a name that you want to run and then running it like this. So here you say docker run and run me Ubuntu container with 14.04 loaded already. Somebody had done it already for us. Somebody prepared a container and installed Ubuntu and installed 14.04, and we just want to use it. So we will say docker please run this container and then run line number 7 for me inside the container, as opposed to locally. So if you run it locally, what happens? It runs like this. If you want to run the same thing but inside a container, you will have to run it like this. Got that? Got the concept, right?
Yeah.
So if I run it, it doesn't know where to get Ubuntu from. Actually, it knows where to get Ubuntu from, but it doesn't have it already. So it has to get Ubuntu first.
Yeah, that's why I was downloading it when I ran the command.
Right. So when I first run it first time on this box, it will find out from Docker registry. What do you mean when somebody says Ubuntu 14.04 and they will have some repositories already available? So there is browse repos and we can search for what repositories are available already here. By the way, Ubuntu, the company Canonical, already provides us with these images, and the way to invoke that is this step. So they already told us that you can use it, and so we are going to use that same thing here like that and create a box create a container containing, not a box, create a container containing this operating system and run this command inside that container. Got it? So if I run it, it will pull down operating system, put that in a container, and then inside there run bin echo hello world.
And it does all this in under a second.
No, first time is longer. First time is longer because it doesn't know where to get Ubuntu from, so it has to get down Ubuntu. So first time, unable to find image locally. And so the image Ubuntu 14.04, the image you are pulling has been verified. So it located it, and then it pulled it down, and multiple steps involved in pulling it down. The status was downloaded newer image for Ubuntu 14.04. And so now we have it, we have a container, we are inside the container, we are going to run bin echo hello world, and there is the output. Right? Got the concept? We went inside the container and something is running, by the way, we just ran it, right? So we have a container running and we ran the application inside the container. So we'll say docker status. No, hold on. What's the command here? Not status. Images. I am also new to Docker. Docker images. So it tells us that we have a Ubuntu machine image created 7 days ago. Somebody created it. We just using it. That's what it says. We have image available for us to use anytime we want. Now, next time if we run this docker run command right now, see how fast it goes. Creates a container, runs it, and comes back. It is running inside the container. It is not running local.
Two separate containers.
So is that a?
It quits. It's done running. So it stops the container also. So this and this.
Is that a virtual machine on top of a virtual machine?
It's a container on top of a virtual machine. It's not a full machine. It's not on top of a real machine. Yes, it's not a full machine though.
Okay.
It's just a container for the application. So I'll go into details. There are lots of steps to go along. The concept here is this is just running directly on the machine, and this is creating a container, running it, and stopping the container.
So creating a container means that you're creating an
Isolated environment to play your application, and your application is
That's all partition.
System. You're just
Okay.
specifying
Yeah,
what
that makes
operating system your app needs to run off of.
Yep.
That's all you're specifying
Yep.
with U-Bounce.
Yeah, so you specify as hey, run it inside this container containing Ubuntu and run echo hello world and come out. And so you run echo hello world just like that locally, but you run like this in a container. It almost feels the same speed it operates, almost like that, but it is a little bit slower. If you run it locally like this, see, watch it. 1, 2. And the next one, watch it. 1, 2. Slightly slow. You cannot visually tell it unless you run the command yourself. The next up, we'll find out what images we have. We saw that. Now we have to set up an interactive container, which is this time I want to interact and live inside the container and play with it. Right? So typically we will operate on a machine in terminal, which runs a command called bash shell, or sometimes zsh, z shell, or some other shell. So we will run bash shell inside a container and hang on to it, not let it quit. We'll run it interactively. We'll operate on it interactively. That's what I want to do next. So the command sequence is very simple again. This time, instead of running it like hello world, I will run slightly different command sequence in which we are saying the same thing, except there is this T flag and an I flag. We are running the same image Ubuntu and running the command bash, bin bash. Now this T thing says that please run it like a teletypewriter, TTY, and I is for running it interactively. So these two are different from the previous attempt. In the previous time we did not have dash E dash I. This time we have it. The difference being we want to run it interactively. So here's what happens when you run it. I'm going to clear the screen and run this command interactively. So it will run the bash command interactively. What will happen is we will start that container, go inside the container, and it will give us a prompt. You will see that the prompt will be different from the prompt I currently have. Our prompt I have is this is my prompt. It says root at Docker, which is telling me that I am dealing with the machine that I created and I called it Docker. Now if I run this particular command, it will create a new container, run Ubuntu 14.04 inside and run the bash shell and give me an access, interactive access to that shell like this, and my prompt changed. I am inside a different machine. The image I am running right now is this.
Looks like a MAC address.
It is a GUID. It's a globally unique identifier, GUID. So it might look like a MAC address, but it's actually longer. They're showing only a portion of it here. So here we can mess around, literally mess around, as in, have you heard of this thing called rm-rf bin?
Yeah, the first.
Yeah, I know. So this is a very dangerous command. You can basically delete everything you want, including delete rm and ls, like fundamental operations of the machine. You can just destroy that. It's a powerful command. It will let you do that, and I want to do it this time because I feel comfortable, because I'm inside a container. I can do whatever I want, including shooting myself in the foot. Right? So I'm going to shoot myself in the foot. Get ready. And I'm dead. What it means is that I can do nothing. I mean, I cannot do ls. Command not found. Right? So I just destroyed my machine. Does it mean that I destroyed my DigitalOcean droplet? No. So I can come out of it, and I have it. It's all there. See ls. And see Docker images, and all of that is intact. Nothing happened. We just went inside, shot ourselves on the foot, came outside. No problem.
If you go back inside, you're still got a hole in your foot.
No, the machine is gone. As soon as you come out, the machine is gone. If you keep
temporary.
No, if you want to keep the machine alive, you want to do certain other things, like to keep it alive, like run like a demon. So it will run in the background and keep running until you want it to die, and then it will die. When it dies, it goes away. So the spelling of demon is slightly different. That's right. And so next thing is we just set up an interactive container and we messed around, we shot ourselves in the foot. Run something inside that container. So we'll create one more container, by the way, and just keep going. So we'll run the container again. We are now again in a different container. Inside that container, I'll say pwd, see where I am in slash, and see ls. I have lots of folders. And by the way, this is different from the machine that I was in DO.
So when you go inside this folder, all the people who go inside, they will have, these are the basic folders?
These are the folders that you will get from any Ubuntu machine.
Okay, that's what I was.
Bare bones Ubuntu, that's what you get.
Okay.
And that's what you have here. But these are isolated copies of what you have already underlying a DO droplet, and you are creating containers inside the droplet, and you get a full environment to play with, including shooting yourself.
It's like restarting Trusty every time. You can screw around.
Right. But see how fast it is.
And then restart from your last and restart.
Correct. Yep. Beautiful. Exactly, that's how it is. So I can essentially do whatever I want inside here. For example, I can go to my home directory, and here I'll say create a file, and I can list it, right?
No touchy.
So run something inside that container. We did that. Let's keep going. Now we want to run a demonized hello world, meaning you don't want that hello world to die after it says hello world. You want to keep it running and keep saying hello world, hello world, hello world. So when you want to do that, how do you do that? So you want to run like a loop, like this. You want to run it like this: bin sh, run inside the shell, -c, while true, do echo hello world, and sleep for 1 second, and keep doing it. basically. And that's what you want to run. So if you run it like this on a plain old terminal, let's come out of this Docker right now. I'm coming out of this Docker and all the way out to my local machine. I'm completely out of DO also. I can run the command right here, and it says hello world, hello world, hello world. It's running, and it is never ending unless you kill it.
Chillo world.
Cholo world.
Hello world.
So I killed it and it stopped. Now let me go inside to our DO. Sorry, in our DigitalOcean. I'm entering DigitalOcean right now. So now I'm in Docker, in the Docker box I created, and this is still not in a container yet. I'm going to run that same repeat command in DigitalOcean, and it says hello, hello, and keeps going. I'm going to break it again, and this time I want to run the same thing, but inside line number 7, but inside a container, and run it daemonized, meaning leave it up and running all the time. So for that, it is not interactive. It is not interactive. So there is no -t, no -i, just -d as in daemon. So you have to run it like a daemon on the background. It keeps running, and it will keep running. It will not show you anything. It will run. It will not show you anything at all, but it will run because it's a daemon. So it will run in the background. So we'll take that command and run it. So if I enter now, what will happen is it will run like a -d daemon, take our same image we have Ubuntu, and run the hello world, hello world, hello world, hello world program inside the container. Got it?
Nope.
Nope.
You said yep.
Oh, okay. I heard no. So this is the command we'll run. What this will do is start a container and start running hello world, hello world, hello world, and it will run alive, not die, because it's a daemon, but come out like this, and we are back into our DO droplet,
Now it's still running.
and the daemon is running, and we have a long GUID, the globally unique identifier here. It's very long. It's more than a MAC address, and this is the identifier for the machine we created in a container, and that is saying hello world, hello world, hello world, hello world, and we want to see whether it's actually doing or cheating. So we can see the logs of that container and find out, hey, show us your logs. The logs will say hello world, hello world. So we want to see the logs, and so we got that container is running or not. We want to find out. So we'll say Docker PS, show me the processes you're running. And by the way, yes, it is running something called bin sh/-c while something something for last 46 seconds, and it has been up for last 45 seconds, and the name of that container is happy_synocy, just randomly generated name.
Yeah, like a Forrest Hawk and Clover Jones.
Yep. Yeah, so you can randomly some adjective followed by a name of a scientist.
Just having fun with name algorithms.
So it's an adjective and a happy Einstein or something like that. You will get something like that. So I got happy Synocy. It must be some famous person in the field of science. So that thing is running. We want to see and check out its logs. So we will say Docker logs. So Docker logs of that happy Synocy. Give me the logs for that machine. Sorry. Break clear. Copy that thing. I'm breaking it. Clear. And Docker logs of happy Synocy. Please give me the logs, and you will see it. Hello world, hello world, hello 47 times, because 47 seconds have elapsed, and so it's still accumulating more lines. Right now the logs will accumulate and grow as you will watch the process Docker PS running. So now you'll have 2 minutes and 120 hello world, you will see it. So it keeps on running in the background saying hello world, hello world. That's a lame application we have, and it seems to be running. And we clean up by saying basically Docker, you please stop. In my case, in the last time I got a boring Heisenberg. So we want to stop that
I watch Breaking Bad.
Docker stop and then the name. So it will stop that name, and this time that machine that is saying hello world is dead. I hope. Please die. It died. So Docker PS should show us nothing. It died. Now we want to do something a little bit different. Like this hello world was pretty boring and we didn't even see it. We saw it in a log, but we did not see it. So we want to create something meaningful. So we'll use this time another application called Flask using Python language. So Flask is like a framework that uses Python language to create web applications. Like Rails is a framework to create web applications using Ruby language. Like Django is a framework using Python language to create web applications. Flask is another framework to create web applications using Python language, and it's very small, so it's easy to quickly start. And so somebody has done that work for us to set up Flask in a container, and we'll use that work, which will give us a ready-made application running Flask and running Python and showing us hello world in a web browser as opposed to terminal and logs. So when we run this particular command sequence, let's examine that, what it does. So next time we are going to run this, and it is very similar to the previous number 9 in that it is also running -d daemon, but another new option pops up, -p as in pencil or p as in port. You have to map some ports.
Also, it means
Port mapping. And so training web app is the name of the container already predefined by somebody in the company.cloud, and they are giving us a ready to use image so we can experiment with it. And this image already has Flask. We just have to run it. And the way to run it is Python app.py. That's how you run Python applications. Python app.py. That's a way to start an application in Python language. So you run the app, you write the application in this file called app.py, and you say Python, run it, and it runs it. And it uses Flask that is already available in this image and shows us the result of the application in the web browser. In this simple example, the result will be hello world, but in a web browser. So slightly different. We're progressing slowly. So we'll take that same command. The -p option is something that I think you should understand. So I'll describe that. So if you know have you heard of port mapping, first of all? Yes or no? Port mapping.
Yes.
Have you done port mapping? Where would you do port mapping?
Find
Linux.
open ports.
Finding those boards.
Basically, you're looking, well, from a security standpoint, you're looking for vulnerability. You want to lock down anything that's open that's not essential.
So you know this port number 80 is where most of the HTTP traffic goes?
Yeah.
You know that?
Sure enough.
Sometimes some applications will run on a port other than 80.
Yeah.
Something like 8080, for example. Some applications run it on 9000. You know, you can run it with whatever port number you want. It doesn't really matter.
Trying to enable exceptions.
All that matters is that port's locked down.
Yes. So on this line number 10, this port number I have, I am running an application in my home. But that port is locked down. So it's only inside the home I can run the application. What if I want to run the same application sitting right here? Can I? The answer is yes, if you port map it appropriately. So I'll now show you an example of how I would map. First of all, the application itself. The application is this. This is an open source application. It lets you watch any kind of videos, movies, TVs, pictures, whatever you want, MP3, whatever you have to have it. If you have it in your home, you can watch that thing from wherever you are.
Yeah, we're running a Plex server.
Yes.
So I can watch stuff that's on my phone on my TV.
No.
No, you have to have it on.
You have to have the thing.
You have a media server. So your Plex server sits on your desktop, you know, your media server, you've got a desktop configured for it. All your movies are stored, all your downloaded TV shows, whatever. And then basically you run the Plex app off of your smart TV or off your Xbox, and basically you stream it from your media, your Plex media server.
Okay.
Yeah, color.
Your own Netflix.
Yeah.
It's your own pictures.
You can download things yourself.
Yeah.
It's your personal, you know, media, Netflix.
Oh, without connecting HDMI or anything?
Yeah, so let me now show you a Plex application right here, right now.
An external hard drive, and it hosts it for you.
Yeah.
Pretty much Google, what's it called? Google, what's that called? Chromecast,
Chromecast.
all of them are working.
So Chromecast is a different game. This is slightly different in that this is you carry your media with you. So my Chromecast is at my home. My media files are at my home. My picture is at home. My music is at home. But I can still listen to my music sitting right here.
It's pretty much like you're asking anything from cloud.
Yeah.
Pretty much.
Yes, my own cloud. Except it's your own cloud.
Essentially a private cloud. Essentially.
So here it is. It's coming up.
Air server.
And it shows you the application, and I'm going to go out to Plex and hope it connects. Hope.
I thought you said you locked it down from outside your network.
Now I have enabled it,
Oh, okay.
and so here I think I should be able to play this.
Great song.
Same mood, right?
Turn your volume up.
But the idea is it'll access any media you have. I don't think it is connecting though.
You got any Bollywood?
No, it's not
Well,
connecting.
no, it started playing.
It
So
started
you hit
to.
the play button.
No, this is like cached entry from when I was driving in. At that time it was playing. I don't know if it's playing right now or not.
It's probably playing in your car. Oh.
Who knows? No, it's not. It's playing here. If it plays here. It's reconnecting. So it's reconnecting. So if it establishes a connection, what this is doing is going to my home IP address and looking for a port number. It did connect. So I have.
Avatar.
Yeah, we can watch Avatar movie
That's
Let's watch it.
just like that.
Did you buy it?
It's already purchased. So I have it.
I downloaded it.
I can still get that a while.
You can do that too.
And so I was watching it apparently up to 2 hours into it. So I can just stream from that point onwards.
Probably credits. Oh no, there's like a 3 hour movie.
Yeah, it's a 3 hour.
Is this the extended version or?
So you have to have a premium account or?
No.
No, it's all free. It's open source.
Yeah, it's open source. You create your own, like, you configure everything.
So you know, some pictures coming up,
Computer running. I have to have
right?
computer running.
So here,
Well, you gotta have
you know,
your
some
files
pictures of some Amish.
stored somewhere.
You have to have your files like accessible. The computer's not on.
Computer's always on.
Okay, so if I use a time capsule for this, I can do it.
No, you have to have Plex server. So enough of demo. I think I want to talk about what is port mapping. So let's talk about that part.
Like enabling.
So what it does is, let's see,
Yes, I would like
this port, Plex server, is the name of a box I run.
Right.
And it produces the output on this port. But my home IP address is from Comcast. And its 43200 is logged because of my router.
True.
Right, so in my home address you will have something like 192.168.0.13, and that's my Plex server. And from outside I will have 67.239.1.142, and so this is logged up, so I cannot reach anything on the outside. You understand the difference between inside IP address and outside IP address, do you?
Yes.
So the line number 4 is outside IP address, That's what you see when you say, what is my IP.com? And
It's your internal.
internal address is this. Line number 6 is given to me or given to my Plex server by the router that I have.
Now, if you're saying your router locks out everything except 80,
You make exceptions.
Exactly.
well, yeah.
So you want to make exceptions now, and you want to tell your router, please allow 432.0.0 on public IP.
Public.
Making exception for your Plex server to grant access through your router.
So that's the thing I will ask. Line number 3 is what I will ask my router to do. Right. So please map port number 432.0.0 on public IP to the 432.0.0 on Plex. And if that mapping happens, everything is okay. Then people from outside can access my machine
If they're trying
if they're authorized.
through the
Keyword,
Right.
authorized.
through the Plex server.
Yeah. Through the Plex, they can reach my home through this port 432 outside into the internal machine, that port through and through, just like I apparently succeeded. Now this is what we need to do inside the container. So what we have to do is, we'll have a Docker machine. We call it, what do we call it? We call it this. Yeah, we call it this. And inside that we'll have a container which will have an internal IP address. We don't know what that IP address will be, and it will have a port, and we need to map a particular port to a particular port on the outside machine so we can reach it, right? We have to do a similar thing here, and this Flask app that we are about to run will create a non-standard non-AT port in the container, and so it will, I think it will create a port number. What port does it take? 5000. So it takes internal IP address colon 5000 that you cannot access from outside. That's what Flask will run internally in the container, and you cannot get to that machine at all, but you want to see what it says. It says hello world, you know it, but you want to see it. You cannot get there, so you want to map it. That mapping is exactly what you do in a router, and the -P option does that thing for us. So what you see here, this -P option is port mapping happening automatically, and we'll read more about it as we run it. So we'll run it right now, and when you run it first time, what will happen? Clear? And it will download that machine image called training web app, and then run Flask application, and then start producing some output on that port number 5000 that you cannot see. So it will also map a port, some other port, with the -P option, and the -D option will run it like a demon. It will never die until you kill it.
So it's constantly granting access.
So it's constantly creating a page and showing you the page, but you cannot see it. So it maps a port, and you go to that different port, and then you can see. And so you cannot go to 5000 because that port is internal to the machine in the container, and so we'll now run it, and it will grab that machine is not available locally, so it will pull down training web app, and then when the pulling completes, then it will run the container, run it like a demon, and come out and say, hey, I'm running it, it's running like a demon on port number 5000, and by the way, I have mapped it for you. Go watch this port. And so it will tell us all that once it finishes. So the downloaded newer image and then gave us a GUID, long ID, gave us a globally unique identifier. This one, a machine ID, a container ID. We got it. We can use it. We can see the Docker PS will show us that this machine ID, as the container ID, this long one, is the same that you have here in this short one, at least for the first few. Right, this segment is the same as this segment, at least for the initial. and here you will also see port mapping going on. See, it says go to port number 49153 on your real computer, and it will get mapped on to port number 5000 for you. So you want to go to the IP address which you now have from DO. Which is here. This is the IP address you got. And so we'll go to that IP address and then also change the port to 49153. So we'll go to the port number 49153 and we see hello world. You got that? So what we are doing is running, what we are doing is this. We are going here to see, and this is the real machine. This is the Docker machine which has this IP address and running on that port number 49153. The container is running it on port number 5000 and it has its own internal IP. You got that? This mapping just succeeded with the -P option for us. So there is a router built in that does this mapping for us with the -P option. So that's what you saw. No worries. So let's find out the logs of that machine that just started. So we'll find out first of all the machine name. What is the name of our machine? It's called Pensive Richie. So we'll go say give us the logs for Pensive Richie, and what do you expect to see?
That.
Query command of somebody querying your site.
So we'll have some simple pleasures of seeing the log accumulated. So I'm going to visit the site one more time and make it a little smaller. A little more smaller, I guess. Yeah, this is good. And break it clear. So we are seeing logs. We see 2 entries. And now somebody visits our site again. What we are visiting is this link, line number 4. We are opening it in a browser like this. And there it is. We saw another entry. Right? We'll hit it one more. I'm going to refresh. Click, 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 refresh, refresh. You see a new log entry populating saying somebody is trying to get HTTP 1.1 and I'm giving it a 200 OK. A 200 OK is yes, I gave it. Success. And a 404 is the error you see when you see a 404 page. Not found. Something not found. What did not found? Favicon not found. Trying to get favicon ICO file through HTTP protocol. Not found. 404. That little icon that you find in the upper segment of the browser is called favicon. If you have seen that before, have you? So if you look at this site.
So if you were to assign it your own icon, then it would do that?
Yeah. If you assign your own icon, your icon will populate right. Watch my mouse.
I remember when our class was that big.
It's here. So if you look at this mouse, you see the mouse? The mouse at the very top. There's a blue icon, little one. That cloud picture. That's the favicon. It's very small. You see in Google Hangouts image here. You see the green thing. You see G+.
Yeah.
You see Google Gmail picture. Yes, everybody has their favicon except this Flask application doesn't seem to have one. But this browser wanted it.
So how do you get it?
So you have to create the app. So it's the app developer's problem.
In the code.
It's the application developer's problem. They did not bother to create a favicon, so it's throwing a 404. And so if you now hit the browser again, and if all of you hit the same IP address and the port, you will see logs and log entries coming up right here. You can give it a shot if you like. Go to this IP address and I'll put this side by side, just hit the page and you will see log entries populating while I am putting my hands up. Just hit that site. So it will be 104, 236, 181. You can do it on your phone if you like. And see hello world. So the idea is we saw some hits coming, and as hits come in, these servers log whatever is happening. And this is an important thing to listen and look for when things go wrong, to look at the logs.
That's what I'm getting paid for.
Look at logs.
Yep. Terribly.
So, yeah, he just told you exactly what he does. So log analysis, there are applications like Logly and Logstash that you should look at. If you're Splunk, you got Splunk. Oh, you got money.
They got money. They don't want to know.
Splunk is another good tool to study. A lot of good opportunity there.
Yeah.
So much logs to go through. It's retarded.
So if you see now the containers process, you will find that it is running, which is expected. We see the site is running. I'm going to break the log process and say docker ps ps, and we see that pensive Richie is running for last 7 minutes.
It's not expensive, so that's why they use X hardware and make it expensive.
No,
Yeah.
it shouldn't. Doesn't really matter, right? Because it's running on your virtual machine, so it doesn't matter if that thing.
Yeah, it doesn't get an extra bill.
Yeah, because your machine is running.
Yeah, yes, there is no extra bill here. Container is on my machine, so my machine is already up and running. You can create as many containers as it can accommodate, and you're golden. Right? Is that your next plan? To run a Plex server? Plex is free download on your machine, that always on, and you can access all your music, all your pictures, whatever, from wherever you are, as long as your port mapping is correct.
You can't run it from an online hard. It's got to be.
It has to be a server.
It has to be.
I mean a PC or a Mac or a
It
server.
has to have, be running some sort of OS.
Yeah.
I can't run an OS on.
You can't do it on, but you can do it on a virtual machine, can't you?
Yes. You have to keep the virtual machine on, up and running. It will be slow, but it will work, kind of, sort of.
So you never, like, it's no longer hosted on your own personal computer, it's hosted on a virtual machine.
So let's look at a couple other things. Inspecting our container. We have to go inspect the detail inside it. So that's exactly what I'm going to do is go docker inspect pensive Richie. Let's see what is inside that machine, the container. So we'll go inside it. The terminology is slightly different. We have to say, call it a container, not a machine, because it is not a machine, but a container. So here, lots of things will come up as I enter this. It's whole boatload of information will just dump like this. And we have to go and examine what this means. This is everything that we know about that container that is running. So we'll go look at that. Some of the key things that you should look at is that it has the image used, training web app. Some other interesting things are that it is the ID number that we got and the machine image ID that we got. Other interesting things that are really useful is the internal network settings. There is a gateway, there is an IP address, there is a MAC address and a port mapping, and you can see the port mapping right below the blue segment.
That's assigned to you, or you could actually program?
No, they just it just gave us this configuration because of the -P option. It created the let's look at this carefully. So I'll copy this segment out and walk you through so you will understand it. Okay, here it is. So let's read this line by line. Line number 1 is beginning to describe our network settings. It says that I'm using a bridge. The bridge name is called Docker. It has a gateway IP address of this number 2. The container itself has an IP address of .11, which is what you will typically get in your home situation I was describing before. like this.
Got it.
Container, IP address.
Container colon 5000 Docker machine IP address colon 49153.
Gotcha.
That's the mapping. It did that mapping for us through a -p option, and inside the inspection command you will find all the details as to how it is structured. So let's look at other things. It will provide us a MAC address. This is like the MAC address for the Ethernet card that doesn't exist.
Yep.
Right, it doesn't exist, it's in a container. Port mapping of 5000 for TCP is mapped to the host IP address wherever you're running. So 00 is the machine, and the port number is chosen as this. If you want to choose something else, you can choose that by using a different option, which is -p, and then calling out 5000 should go to 6000 as opposed to go to 49153. You can call out exactly what you want.
Okay, so
You can override. Yeah, capital P will automatically do it for you, but if you want a specific thing to go to some other specific port, you decide what you want, and then it will go there. So that was this about inspecting a machine itself, which is you look at the details inside the container, and it gives you a whole lot of useful information, and you can make use of it, or you can tweak it through other commands. Like if you want to just get a particular segment of the item, that you want to just get the IP address for the machine or for the container, you can go something like this, and then followed by your machine's title. What do you have? Pensive Richie. So you have a title assigned to that machine, so you copy this command, and instead of full inspect the whole detail, you just go get me the network setting.ip address, and you got it, just that portion. So you can extract whatever information you want from the uber command, which is docker inspect. It gives you the whole thing. You can selectively grab whatever you want, or you can just visually see what you want.
What is the -f command?
Where?
Is that just a find on the Docker inspect?
Yeah, find.
Okay.
It's like an IP control.
And then when you're done with it, you just want to stop that thing so it dies. So you can say docker stop and then pensive Richie, and it dies. You killed it. So here's how I would summarize. I'll think of it this way. What this let us do is very efficient, very low consumption of resources. We are actually taking the smallest possible virtual machine you could get on DigitalOcean and run a container inside there. Try doing that, a VM inside VM. You will crawl, literally so slow. You heard me saying run a VM inside VM, or you run Trusty on your laptop and you complain already, right?
Yeah.
And so we already took a VM and ran a container in there comfortably, no problem. Did not slow us down.
Because it's not one of our local resources.
Right, it's no resource hog at all. Very negligible resources are consumed by the infrastructure itself. So you can create containers and create your applications in there. We also found that we can shoot ourselves in the foot if we want to, not that we will, but can, which basically tells us that it is protected from anybody else. It doesn't destroy anybody else. If you want to make a mistake, or if somebody makes a mistake in code, that particular container will go bad, but nothing else will.
That's why you use those environments to test out
Mhm.
new
Yep.
production systems,
Yep.
changes to productions, systems, stuff like that,
Yep.
so that you can
Yes.
foobar it.
Fubar.
Not have to worry.
Fubar is it's a military word, is it?
No.
Yeah.
So, it stands for effed up beyond all recognition.
I know, but there is a military connotation also. Somewhere I read.
You hear it in the military all the time.
Yeah, you hear it in the military, but no, that's
No. There is a.
Number of military slang or acronyms.
It's a military slang.
What?
Yeah.
Yeah, it's
That's how I know.
That'd be different.
So it has. Fubar has a meaning apparently.
Tar food, I like that.
What tar food?
Totally and royally.
Yeah,
Food bar brand Bundy. Wow.
but not dead yet.
Oh,
The chicken bingo.
By the way, these nerds, they will use this word foo, slightly different in bar.
Yeah.
And this is like, how do you describe this? What's the, is this the first time you're seeing these words?
No.
No.
No?
This one.
Isn't there like a buzz?
F-O-O-B.
Buzz too?
Fuzz buzz?
What?
What?
Barbados.
Yeah, these are randomly generated words that technical people seem to love.
Buzz buzz.
I don't know.
You mean like a meme?
Yeah, it's almost like a meme.
They even asked this in a programming question. When you
Yeah, in fact, most people,
Like,
there is this, you may have heard of this Acme Corporation.
yes.
Yeah, you heard of this company?
No, yes, in Looney Tunes.
Yeah.
That's right, that's what Fubar and Baz and one more.
Company, is it Acme is
Yeah.
any company, something.
Exactly, so anybody can be Foo, you can be Bar, you can be Baz, you can be Cooks. This is how people talk. I'm just saying.
It's just slang for IT.
It is slang.
Hua.
Yes. Got it. Yes, this is like Acme.
Guys.
Like you can label it to anybody and everybody, or
Hua.
yeah, it's not Hua. And what? One more thing I wanted to say about this Hua thing is,
It's not so much social media.
yeah, this you will not find on social media, but you will find these examples in Dilbert. And so you will, if you want to look smart in a discussion, in a technical discussion, you will use, let's call a machine foo or a person foo. And that certainly makes you smart in the family.
Competitive food.
Yeah, I seen food like that, like Mr. T called someone
Right.
food.
So this,
Like a
have you seen this word John Doe, Jane Doe?
Yes, those are,
Yeah. See,
and
yeah.
anonymous generic name.
yes. So that's what Acme would be, and so you can use foo and bar and for 4 different people, and that's how it is commonly used. Just so you know. So the word foo bar is different.
What's an acronym?
What is a bar then normally?
I'm used to seeing that one.
Yeah.
Yeah.
Yeah, number
actual
no,
acronym.
yeah, number
Bar is an
2 is acronym, but these line number 4 is not. But this is generally used. Let's do a search on that. What that means? I don't think it means anything.
Flux.
Yeah.
Flux. Medicine. Someone just misspelled that.
So not to be confused with foo bar. So it says that clearly.
Here.
Right, not to be confused with foo bar. Foo directs here. The terms foo bar and foo baz cooks, and sometimes cooks, and sometimes norf
North.
are used as placeholder names, also referred to as metasyntactic variables. So this is okay.
Just random
Yep.
variables.
Exactly, you use them as random variable names to call anything whatever you want, just like Hua.
Important.
Got that. So we have stopped the container that we did, and we can check if it actually stopped. So Docker PS L will tell you that this thing was stopped 5 minutes ago.
Timey wimey things.
And by the way, you can restart. So if you have an application container that somebody just wants back, hey, I want my machine back, you can say, what was the command sequence? Docker start. Yep. So you can say Docker start my pensive thing again, and it starts again. So now you will see in Docker PS, and it is up in the last 6 seconds. And by the way, this time the port changed. So you have to go look at different port, because if the old port, if you go to the same one, it will not show you anything because the thing is dead. So you have to go and make the changes to the port. This time it is 5.4, and now you should see Hua. So you can recover if some machine gets shut, some container. My terminology is not up to speed on Docker yet. So if some container gets shut down, you can restart it, and it brings back up.
There you go. So
And-
defaults.
Yeah, it doesn't go away unless you really want it to go away. If you want to really want to remove it, you stop it and then you RM. So you Docker stop and Docker RM, then it goes away forever. So here the terminal will say Docker stop, first of all clear, Docker stop pensive, and it will stop the machine. You can start it again if you like, but if you Docker RM, then it's gone. Then you cannot create it again.
Actually, I got a quick question for you. We don't have a Saturday class.
We can do that if you like.
Because I was wondering if we could make like, so this is a simple application, right? Can you make your own custom cookbook real quick and show us like how you do that in a chef
Yeah.
application to where you create a cookbook?
Yeah, I have it already. I showed it to you like long time ago. We do it again. I took 15 minutes.
Oh yeah, I remember the instant gratification one.
Yeah. I do it again.
Gotcha.
Anytime.
Okay. Sad.
And give you the code to play if you are interested.
Because I want to see how to make your own. Because I saw some of our DevOps dude like create their own, because they have their virtual boxes, right? So they launch their cookbooks to their virtual boxes using their.
Oh, easily.
Yeah.
Very easily done. So you can bootstrap a virtual box using Vagrant and run Chef. Vagrant is another application that's, you have to install it. You don't have it.
So who's running the email? Got it. Okay, got it already.
So Docker RM pensive will kill it. And now it's gone.
No, nobody's letting past the time.
You want to do some extra credit? Extra credit work is also available. Unless you want to go home.
Whoa.
What is that?
I have staff duty right now.
Create a snapshot.
Right now,
Yeah.
How you got staff duty?
Till 8.
That's terrible.
No, till 8 in the morning.
Well, at least you have to come to class.
so the extra credit essentially is that you get to create your own images and push it to Docker Hub. So next time somebody else can grab that image and run with it.
So make sure it's FooBard.
Or not FooBard.
I think we should have kind of learned on the how to create custom cookbooks. I think that would have. You kind of did show us on like your
Program guy?
We can do that. Saturday.
do a little bootstrap.
Yep.
You have the network configuration.
That would be more practical. Like,
Makes sense.
we can do a lot of like observation. I mean, your tutorials are great, like exercises, but I think like just knowing by hand, like yeah, I got a little bit of experience of how to do this.
What's your casework, Bob?
At least just like how, doing a print hello world.
Yep.
You know?
Makes sense. And totally do that. We should do that totally.